My name is Mathieu. You can call me Matt. I'm working for Genie Mobile. It's a French company in Paris. I'm working there as a system engineer. But today I'm going to speak about building how you can build an Android ROM for your phone or for your tablet. I'm going to talk about that with a strange way. We will pretend that you have never built any ROM, and we will be following your first try. So it will be a bit like a role-playing game. So what can you expect from what we'll see today? So first we'll look at the sources, how you can get them. Next, how to build that. I put an underwear because we will look at what's inside Android, so we will get Android a bit naked. After that, we will try to build it. At the end, we will try to flash what we have been building. It's what you can expect, but in fact, it's the first time. We will do some mistakes, so it's not maybe we will build several times some things and going back on the configuration or for fetching the sources. As I know it's late, and you may be a bit tired because of the day, I have plenty of goodies. So if you have an interesting question, or at least something related to what I'm saying, you have the right to get a goodies at the end. Yeah. So let's start by a little story. You are a geeky guy. You have been trying all the last Linux distribution on your computer, and you get an Android phone, and you are asking yourself, maybe I can try some new distribution on my computer, on my phone too. And you also know that Android is an open source project, so maybe I can also build this distribution for my phone or my tablets. You start by Googling, and you find this website. It's the official one. It's called S for sources, sources.android.com. And you have there a lot of information about how to get the sources, how do you build them. And we will just start by the computer that you will need for that. I will help you for this part because the information you can find on this website are a bit outdated. You need at least 60 gigabytes of hard drive because those are taking a lot of memory. You will need also a 64-byte system. It's also advised that you use a Ubuntu distribution. If you want to use something else, I know that you can build it with a Macintosh, but I've never tried it. And if you want to try to build it inside a virtual machine, it's not a good idea. You can try it, but you will fail. So, one of the first instructions on the website is installing the repo tool. So it's the first time you may have heard about this tool. What is that? In fact, the Android project is made around 200 external projects, 200 external Git repository. To work with all those repositories together, Google built a new tool. It's called Repo. So the goal of this tool is just to fetch sources from several repository and switching from branch to another on all those repository. All those Git repository are defined in the manifest. It's just an XML file saying where to find a repository, where I should put them when I check out them. So the first command you will use is repo init, then the manifest you want to use, and we can also specify a branch, the one you will use. So maybe not necessarily the developing one, because maybe it will not compile. And at the time of I was making my slides, Those one was the last one, so it's the last KitKat version. Then, so here you just configure where do you want to get the sources. The next step, repo sync, will actually get the sources. This one will take a lot of time. You have to download about 20 gigabytes of sources, so you can have your first coffee of the day. When it's downloading, let's look at what you will find in your directories. So first, you will have a folder called Bionic. So Bionic is the rewrite of the C library for Android. Google has been starting that from scratch instead of using the libc that you may have on your computer. It's optimized for embedding and for a small size. We can also, oh yeah, and it have another license. It's not a GPL license, it's a BSD license. We will talk about, more about that later. You also have the bootable directory. You will find in that everything that's needed for the boot. So the bootloader, and also a tool that you will find very helpful later that's called recovery, that will help you to flash new system version. Next directory is the build directory. So you have plenty of things to build and to configure. You will find all the definition in this directory. And all those files are built around the tool make, so it's all make files. The CTS directory, we will talk about that later, but it's a compatibility test suite. Okay, this one is not really in the alphabetical order. Dalvik or Art are two directories representing the virtual machine. As you know, the top applications are written are running on Java, so you need to have a virtual machine. Those two ones are specific to Android and have some special optimization. We can talk about that later if you have some question about that. A development directory. In fact, you will find some tools there, but they are not really interesting. Another directory which will be very important, the device one. You will find in this directory all the configuration specific to each target. So if you want to have something special for a Nexus 5 or a Nexus 10, it will be there. The documentation directory, it looks very promising, but in fact it's just the source of the website, source.android.com. So not really a documentation there. Another big directory is the external. So as I said, Android is made of several external projects. For example, SQLite, bzip, FreeType, and so on. And it's all using a lot of them, so you will find there in this directory. The framework one is where the API from Android is written. So anytime you write an application that is making a call to something in Android, it's implemented in this directory. There are hardware directory, we'll talk a bit about that later, but it's all the things that are specific to the hardware. libcore is the implementation of Java. It's not the Java from Sun or Oracle that you have in Android. It's libcore. You also have the sources from the NDK. Maybe some of you have already used it. The out directory will be very interesting because you will find the result of your compilations, or anything that will be built will be in this directory. Package one, you will find the base application, so SMS, the camera ones, all the some of the interesting application are there. Pre-build, regroup all the compilers, the debugger things. SDK is the sources for building the SDK. In system, you have some of the tools that are used by the system for configuring the whole thing, like the init system. NetD is for dealing with a network. Volde is for dealing with hard drive, mounting hard drive. And the last one will be a vendor. We will talk a bit about later. But let's say about 5 hours have passed. You have finished to fetch the sources. And you're all asking to me, but Matt, where is one big thing is missing, and it's, give you some help, plenty of goodies. No? For that you need a driver. And of course the root core for that is the Linux kernel for Android. You will not find the source of the kernel in the EOSP, so the Android open source project. You will find the kernel only in the binary way. Usually you can find the sources of the kernel, but they will not be here, so you have to make some more research. So we continue to follow the rules on s.android.com. The next command will be source and a strange file, build and setup. You have plenty of things that will be written on your screen, and you're feeling that there is some kind of black magic around there. So you start by looking at the file. You have some interesting comment at the beginning. It's declaring a lot of interesting tools. And even if you won't build an Android anymore, maybe you can take some of them, like a cgrep or a ggrep. Will be looking for a string in all your C++ or Java file. It can be interesting anyway. So I will explain a bit more about this black magic. As you can see, the source build and setup is looking for all the vendor setup.sh file that are declared in the device directory. As I said before, the device directory is for all specific stuff to a directory, to hardware. So at the top, you have the content of vendor setup.sh. So it's just a command, add long choke combo, that will be add to your environment, target name dash and a type. The target type will describe the hardware you want to build, like Nexus 5. And the type will be engineering, user debug, or release. So of course, release will be the one that you want to share with public. Engineering will be the one with the full tools for debugging, and the one you can have. It will make ROMs when you can have root access, and the user debug is the thing in the between, when you don't have all the tools, but you can pass in the root mode for your ROM. Okay, so you have add a launch combo, target type, target name dash type. So if you are declaring target name, you must also have a file called androidproducts.mk, where you should have the same target name.mk that will be declared. Anytime, target name will be including a file, then another file, then another file, and at the end it should be including, oh yeah, sorry. This is a real example for the Nexus 5. So this is the vendor setup for the Nexus 5 that is called Maret. It's the name, the internal name, and the content of the Android products. So yeah, the Android products will be including some file, that will be including some file, that will be including some file. At some point, it will be including a file that's usually called device.mk. The goal of this file is to describe the software that you will have in your ROM. So it will describe the application that you want, some of the file, the configuration file that you want also. It heavily reposes on the inheritance, as we will see, and it's usually called device.mk, but sometimes it's another one. So again, this is an example from the Nexus 5. Here, as you can see in green, you have the product copy files. that will copy the kernel in the kernel partition that we will build. You also have just behind the copy for the configuration file for the starting, and so on. This is the continuity of the file. You have the description of some of the application that you want to install. So it's product packages. So I don't want to describe the application, but it's where it's done. You can also see at the end that there is a lot of inheritance. Just you to know that everything is not described in this file and you have to search in something, in something, in some things. For example, let's say for the first line, the Dalvik heap, so it's the configuration usually made for the virtual machine. You usually use all the time the same one for when you have a particular screen resolution. There is another very important file. It's called board config. In the first one, we have described the software. Here, we more want to describe the hardware. So, as the first one, it will also include all the files. And here you are describing much clearly what you want to build. Here is also the example for the Nexus 5. So you are targeting an ARM architecture. Here we're also describing that you are using Bluetooth. You can find a Bluetooth on this phone. The CPU is a crate one, so it's a particular version of an ARM one. Okay, let's back to the manual. So you have been sourcing the file, build the setup. It has been including all the vendor setup. Next, you can launch the next command that's called launch. So vendor setup have set up a lot of targets, and the launch can show you them. So here you can see that you have about 40 different sources, targets. So the Nexus 5 is the Maret, the Nexus 4 is the Mako, and the Nexus 10 is the Manta. If you don't have a Nexus device here, you will not find here. In fact, the OSP, so the open source project, will only build Nexus for Nexus. Some other builders, some other factory has some open source program as well. If you have a Sony, maybe you can find all the sources for your devices, but it could be very hard to get all of them. Okay, we have everything prepared. Now we can build it. So again, it will take a lot of time. You have plenty of files to build, and it's time for another coffee. Just to be sure that you know, Make can do several jobs in parallels. That's why we are using the -G. And here we are using a crazy name, but usually a crazy number. But usually you put the number that's about the number of CPU that you have. I will just explain later what's going on. So you have plenty of source. I said about 20 gigabytes. We will see about how they are organized and how the build system know to build them. So any things that need to be built, it's called a module on Android. Android is about 2000 Android.mk. That's why it's taking a lot of time. Just show you some example of Android.mk. So maybe you have already used the little tool that's called SU. It's helping you to get root rights on a computer. Here is the definition to how to build that for your phone. So it's specific to Android. Here, you always start by cleaning what have been done before, so it's why you include the clear vars. But the important parts are where you describe the file you want to build. So it's local src files are. You declare the name of the module, SU, and if you remember in the device.mk, there is a definition of all the package you want to install, and if you want to know the name of the package you want to install, it's described by the local module. So if you want to install SU on your ROM, you have to provide this name in the local package name. Okay, some other little stuff like I want to build it with the static C library. At the end, you have the include build executable, and this line will take care of you of the different CPU architecture you may have asked, and will build an executable. You have plenty of different definition, and I will not talk about all of them. So if you want to have a clear view about all of them, just look at the file that's called build core clean vars, because cleaning vars will clean all the possible vars. So here is the best way if you want to know all the possibilities. Just one more thing, it's the local module tag. It's describing that it's a debug tool. So SU will be included in the engineering one and the user debug one, but not in the release ones. That's part of the difference with the engineering and the release ones. Okay, let's pretend that 5 more hours have passed. You have something that have been compiled. Okay, what can you do with that? The compilation process, I've been producing a lot of images. So as I said, you can find them in the out directory. They have all name finishing by EMJ. So they are representing the partition you can find on your phone. The major ones are a system, where you have all the application that will have the particular rights, or the implementation of the Android API. User data will store all the application you want to install. So if you go on the Play Store and install something, it will be stored on the user data partition. Recovery is a tool that you can start at the boot of your device, and that can help you to save some data, install a new version of your system. RAM disk is a very important one, and a bit strange one. It will contain the kernel, but as well the definition and the configuration for a lot of files on your devices. That's if you have already tried to hack a phone, you maybe notice that if you make a modification in the file that are on the root path, they will not persist on the second reboot. In fact, it's because it's a RAM disk, so everything is it's written from the hard drive and stored in memory. So you can try to modify that at the next reboot, it will be lost.
If you compile all this and you have the images, can you put all the data to the update.zip file so you can flash it through recovery?
Okay, so the question is, here we have produced some files .emg, but can we produce also a zip that you can use to update your phone as well? The answer is yes. You better have to have the previous version that have been built for your ROM, because it needs to be compared to build the zip file. Sadly, I think you will lose most of your data as well. But it's possible, it's possible. And it's just another target. You don't type just make, but make update image or something like that. I don't remember the exact name.
And the sign-up process is already in the procedure, or you have to...
What process, sorry?
Sign up, because when you try to flash update.zip,
Yeah.
it has to be signed.
Oh yeah, the signing process. Okay, sorry. My English is not that good, so yeah, of course it will be in. We will talk a bit more about that later, and I will try to remember to talk about that. Okay. So yeah, plenty of image, how to flash them. Oh yeah, and we will gonna talk about them. So you have to reboot your device in the specific mode that can flash images. So you reboot that using the ADB commands. So ADB reboot bootloader will put your device in a special state. It will be waiting for a special command to flash it. And the tool to use to flash is fastboot. So fastboot flash all will try to flash all the images on your phone. If the ADB and fastboot command are not already in your environment, you can build them using the make command just behind. In fact, the last command will not work because your bootloader is configured to only load ROMs that have been signed, that have been certified to work on your phone on your tablet. It's we can say it's a security to make sure that you have something running on your phone that have been approved by Google or by your OEM. So you need to let every ROM that have not been signed run on your phone, and that's called the fastboot OM unlock. It's easy to use on Nexus phones, but if you have another brand, it may be much harder than just the fastboot OM unlock. The fastboot OM unlock may wipe all your personal data, so don't do that just for fun. But anyway, all the things that we are doing will remove all your data. So. And I think from that you can also use any .zip file that have not been signed as well. Okay, so ADB reboot, bootloader, fastboot OM unlock. Now you have a bootloader that accepts anything, so you can really flash your device. Yeah, you have built your RAM, you have flashed it, and it's the first try, and it's not working. So you can cry because you have it's called breaking your device, because it's called bricking your device, because you just transform your device in a brick, you know, for doing walls. It's not useful anymore. No, it's not that important. If you are looking to the original system, you can go to the site that just behind, and you will find the factory images. So look for factory images in Google, and you will have that popping up. But why it's not working? I'm going to explain a bit about that. And we are talking a bit about licenses now. As you know, there is different licenses in open source. So the major, one of the most famous one is the GPL. It's used by at least the kernel in Android. And in the upper layer, at least for the framework and some of the application, you have the Apache version 2, I think, version. The GPL, if you use the GPL, anytime you modify the GPL code, you must give your modification with your binary. So any constructor that needs to modify the kernel for adding his own driver may have to share the modification and share all these secrets with the rest of the world. It's not the case with the Apache license. So having the GPL may be an issue for the constructor, and so it could let some constructor not use Android at all. So Google designed a new architecture. So yeah, it's a bit hard diagram. At the bottom, you have the kernel, that is GPL. As you know, it's the only one that can talk with the hardware. It's the system, the base security of the system. But as you have at the top some things that need to be connected with the hardware, the Google project had what's called a HAL, so Hardware Abstraction Library, in the between. So it's just a library, so running in the user space, that is using the Apache license, and all the things that are really interesting and bright are written on those files and not in the kernel. Usually, as you can only talk with hardware through the kernel will have some driver, but really small one. If I take an example for let's say a sensor, an image sensor, on the kernel we just have the definition of the I²2, so it's the way to communicate with the sensor, and all the things that are interesting, like how do you configure the array of the sensor and stuff like that, will be put in the file and a .so in user space. This user space file we have can have a different license, so it's okay. So yeah, you plug a cable on your device. You are launching the debug tool that's helping you to get all the log from your device. It's called ADB logcat, and it's crying because a lot of drivers are missing. Yes, those drivers are not given in the IOSP because they are not necessarily open source. So you need to find them on internet. For the Nexus devices, you can find them because they are given by Google. When you download them, to use them, you have to accept some particular licenses and some stuff like that. So you get your drivers. The instructions say you have to rebuild everything. So you rebuild everything. You are, let's say we have 5 more hours left, and it's still not working. So you plug again your cable. You are looking at the log files, and the driver you have been installing are, for the Nexus 10, they are complaining because some of the drivers are still missing. Some firmware are still missing. Okay, looking for other drivers. So when you read the manual, there is 2 kinds of drivers given. The first are the official ones. The second are the blob preview. Okay, maybe we can try with those ones. Remove everything, recompile everything, and it's still not working. This time, on the Nexus 10, it will be complaining because of some misunderstanding between the driver you just installed and the libc library. So what you can do, you will have at least to rebuild everything one more time, because it's the 3rd time you rebuild everything. I'm telling you that you can use a tool that's called ckh. Anytime you have compiled a file, ckh is a very, you can use that in every major project. So every time you compile a file, it's saved on your hard drive somewhere. And if you recompile this file later with the same option, it will just take the file and not recompile it. So it's saving a lot of time. As you already compiled the full Android for maybe 3 or 5 times, you have been losing a lot of time. I'm giving you these tips. So yeah, where will you find the correct binaries? In fact, we will get them from the factory images. Those are giving with the correct ones, with the correct library version, and all the compatibility things that have been solved together. So you download the file for your device, and you just have to pick a particular directory that's called vendor that store on this one. Okay, so you put that on your device, and this time it's working. Yeah, at least. But when you start it, you will notice that a lot of things are missing. It's good for the hardware. The hardware is working fine. You have the Wi-Fi, you have the Bluetooth, and all the cool stuff. But you cannot install any application because the Play Store is not available. Google Maps is not there too, and plenty of applications are missing. You are missing what's called the GApps, so the Google application. To make sure that all the different devices in the wild are correct and really running what's called an Android, Google makes sure that you have to pass some tests before being able to use those applications. So you have a document that's called the CDD, the document definition, that's saying, for example, to have a branded Android device, you must start your browser in less than one second, for example. So that's all a lot of definitions. You have a lot of automatic testing that you have to pass after that, so it's called the CTS. When you have finished the automatic testing, you have some manual testing as well to do, so it's the CTS verifier. And when you have finished all those stuff, you still have to send the results to Google, and maybe they will let you use the Android trademark and install the Play stuff on your the GApps on your devices. So that's a part of the thing. Google makes sure that you are a real Android device to have access to the Play Store, to Gmail and stuff like that. But the other part is that Gmail is not an open source application. You have some applications that are given with the project, but all are not open source. In fact, fewer and fewer are open source now. Maybe, I don't remember, you have the calculator that is still an open source one. Cool. The contact one, the dialer one, and the clock one. Yeah, it's cool for your phone, huh? Okay, so that's what you are missing here. I'm not sure that's legal to teach you how you can get the GApps on the internet, so I will let you do that on your own. It's a bit late, so maybe you have been sleepy tonight. Just to sum up all the things that we have been doing, and in the correct order. So first, repo init with the correct repository. If you are using something that's not a Nexus device, you may have to look a bit on that, maybe on some strange website. Repo sync will get all the sources. Source build and setup will look for all the possible configuration in your sources. Launch will help you to select the device you have to compile. Then you have to find the correct binaries somewhere on the internet. After that, you can build. Then you have to unlock your bootloader, so it'll accept any kind of system images. Fastboot flash all will install your stuff, and at the end you can look for the GApps. If you want to dig further in this subject, this book is very nice, very interesting, and well made. It's a bit old now. It's about the 4.0 sources, but it's still very interesting. I've been stripping some copyright from the example I've been showing, so here is the copyright. And that's all. Do you want some goodies? Or do you have any question?
What about the kernel? If I use the stock one, it will be okay, but I would like to use third-party kernel to my ROM, and it may have some problems with missing parts. So can I, for example, make some hybrid between the stock one?
Some what? Sorry?
A hybrid. Put together two kernels and make only some parts from the
Okay, yeah.
into one.
Yeah. Sorry, so what about the kernel? Can I tweak it, get some part from another kernel, for example? That's what you are talking about? Cool. So yeah, you can find, usually you can find the source for the kernel for any devices because it's an obligation. The manufacturer have been modifying it to run on this specific device. As it is GPL, you can ask for the source code. Yes, you will find the original one that's running on your phone. After that, if you have the capabilities to know what's the best particular part you want to bring back, yes, you can do that. As I said, after that, the kernel is embedded in specific image that in the RAM disk. So you have to rebuild this image as well to have it on your phone. So yes, it's still possible. Is that answering your question? Cool. ARM? Art. Oh yeah, good question. Recently, Google have been doing a new virtual machine. So the new virtual machine is called Art. So this guy is asking me if Art have any particular interest on the old virtual machine that was called Dalvik. The answer is yes. They have two different ways of working. The original one is just interpreting bytecodes, by the way, so it's a typical virtual machine. The new one, Art, is add precompiled code. So when you install an application, it will be given to Art, and it will try to already compile some parts that are really useful, so those parts can be used as a natural binary and don't have to be reinterpreted at the runtime. So you are saving a lot of time and stuff like that. But it's taking a lot more of time at the beginning. For the 4.4 version, you have the two virtual machines that are living side by side. You can change them in the developer menu. I think in the last version, in Lollipop, you can only have Art. Other question? We have some Genymotion free trial. Okay, that's all. You can